Homework answers. I didn't post them. I'm going to probably stop posting. Some of us are just doing a horrendous job. Either we're just copying or we're just doing a horrendous job. Your tests were not very good, and that was probably the easiest test you're going to have all year. The free response was absolutely the easiest you're going to have all year, and that was kind of disappointing, especially like some of you guys got 0 points. 0. So we got to start doing better on our homeworks. Bottom line on that. Number 1 was exponential. The reason why it's exponential, you got to know this reason, because if you don't put this reason, you're going to, it's wrong. Okay? Over equal lengths inputs. Equal length inputs, the outputs are proportions, or the outputs are multiplied, or something to that effect. But you got to talk about the equal length inputs and the outputs being proportional or being multiplied or divided, or whatever you want to say on that. Okay? The work is pretty good too. Remember, you can show it mathematically, verbally, or graphically, right? If it's multiple choice, you don't have to do anything. But if it's a free response, you got to have something there, right? So 1 was exponential. 2 was neither. Difference here was 1, and then 1, and then 1. So I'm sorry. What? Yeah. 1, then 2, then 3. It was quadratic is what it was, right? Because the second difference is constant. If the second difference is constant. But then you still got to talk about equal length inputs. Equal length inputs. So that's why I always had you guys do that subtraction on this side. You always want to make sure those are equal length inputs. Okay? This was divided by 2 or multiplied by 1/2, either way. So that was exponential. And then this one was linear because the difference was a constant. So over equal length inputs, the difference is a constant. You guys good up here? Rian, you good? Okay. If you say so. Number 5, 320,000 people will have the mean by hour 10. 320,000. Anybody got a question on that? 320? Their work's different than your work, I'm sure, because I kind of showed you a different way how to do it. 320,000. And then number 6 is 34,500. 34,500. And make sure you put it always in context. Flights have begun across the United States by 6 p.m. Any question over that one? 7, 2,000. 2,000 bald eagles. Oh, I'm sorry. In 2000, there were 12,470. I'm sorry. 12,470. That was good for worksheet A. Worksheet B. Exponential for 1. They were multiplied by 2, so over common inputs, the outputs were proportional. Number 2 was neither. Same thing, it was actually quadratic because the second difference is constant. You'll need to know that, right? At some point, you're going to see just something at random, a table, and you have to figure out if it's linear, quadratic, exponential, sinusoidal, all kinds of things, right? Number 3 is exponential. Again, equal length inputs. The outputs are proportional, or the outputs are divided by 3, something to that effect. You just got to talk about the multiplication or division. 4 was linear. The difference was 2.5, negative 2.5. They talked about the over equal length inputs. The outputs were constant. So again, I think the work is okay, but I think you need to have those inputs. Okay, everybody okay on those? We'll do those today too, but they're not going to. We'll do that today. Whoops. On a marker. It'll go away. Go away. There you go. Number 5 was about 5630 rabbits. 5629.68. And then 6 was what? 2583.7. Typically a calculator multiple choice question. One of those. One of those. Of course, your test will, but that's even one on the AP test. Yes, no, maybe? Easy peasy, hit me. Where are we at? On that one? 25,836. Yes, that'd be all right. I think. That's what that says. That says 25,836. Was there decimals after that? I think one of those. What did it say to do anything? Did it say to round? Yeah, you can in statistics because you're trying to predict about. Yeah. I mean, did it come out whole number? Yeah, because it's 2100. So I think that they must have mistyped that. He must have mistyped that. He must have mistyped it because that looks like 25,83.6. Passwater does the worksheets and Ted Gott does the answer sheets. Passwater does the worksheets, Gott does the answer sheets. I text Gott every once in a while when I see that. I'll text him because we're ahead of most other schools. So I'll tell him that. Yes, no, maybe? Easy peasy, lemon squeezy? Any questions about notation or work or anything about that? How's he do it? He sets up an equation type thing. I just told you to divide and then take whatever root. That's what they're doing too, but I just think it's easier to do it. They don't care how as long as you show something. So if you show the 343 over 64, and then you're taking the cube root of that. If you just show that, that's fine, and you say R equals, because what is R in? R ends up being, R is not a, oh no, R is 7/4. So you got R is 7/4 in there somewhere, you're good. And then you show 7/4 times 60, or 7/4 to the T minus, just don't have naked answers. Don't have naked answers. If it's free response. Just be able to follow it. Now, again, your test had a lot of naked answers because there was absolutely no work to be shown. But I mean, how it asks for the vertical asymptote and it's already factored. I sometimes just don't understand. Okay. Everybody happy? 2, 3? Man, this is the easy one. We'll get done early today. Not yet, because we'll do that Monday. We'll do test Monday. There's still a couple of kids that have to take it, not of ours. Not of ours. 2, 3. 2, 3. So unit 2, guys, we mentioned it, and I hope you're kind of picking up on it. Unit 2 is exponentials. It starts off with exponentials. Unit 3 is trig. So we'll do it after Christmas. But unit 2 is pretty much exponentials. And so it starts off fairly easy because you're familiar with a lot of this exponential stuff. We're going to get into it a little bit more difficult. In math, we study several types of functions, 3 types of functions to seem to keep showing up in math courses from Algebra 1 to Calculus. These 3 families of functions are also predominantly on the SAT and the ACTs. So that's good stuff, right? Linear, just 2x, quadratic x squared, and then exponential 2 to the x. Of course, it could be 3 to the x or 4 to the x. Of course, all this other stuff, we have some shifting. But we know what a linear looks like. We know what a quadratic looks like. And then this is exponentials. What's special about exponentials is they have what? Horizontal asymptotes. Okay, they have horizontal asymptotes. At no point will 2 to the x ever be negative. X can be negative, but if x is negative, that just makes fractions. So that's why it just gets closer and closer and closer to 0, provided that's not moved up, down. So exponentials. Rationals, they didn't put up here, but that was all last chapter also, right? Exponential functions are some of the most important functions in the real world. They appear in many places, including population growth, money, whether it be interest or debt, radioactive decay, spread of disease. In addition, the SAT will include several questions that require an understanding of exponential functions. So, an exponential function has the general form a b to the x, and we've somewhat seen that already because you guys, we saw what g sub n equals, and then we did a sub, did we do a sub n or anything? We did r to the x, and we did n minus 1, right? Okay, yeah, similar to that. So we have a, which is a initial, not like RM. Those are my initials. I need a serious laugh. Nope, it's fake. I think I stayed out of the way of the camera. Okay. B represents the ratio, the base. I don't know what you really want to call that. I guess base. Ratio. It's several things. I think they call it base. Let me get that light for you. Here comes the sun. Do, 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 do. It's all right. Okay. All right. Here's what you need to know about these things. Y'all did exponentials in algebra 2. Yes? 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 You did logs in algebra 2s? You still do logs? So if exponential growth and exponential decays. Growths start off somewhere, some horizontal, and then take off. Decays start off high, branch off to an asymptote. Okay, decays. For a growth and or a decay, A has to be bigger than 0. A has to be bigger than 0. Because if A is less than 0, that reflects it over the x-axis. If A is negative, all it does is reflect it. And they're no longer growths or decays then. They're reflections of growths or decays. I used to trick my kids back when pre-AP. I would trick them and I would do this right here and ask them if it was a growth or decay. And it's really neither, because A has to be bigger than 0. And so it's a reflection of a growth or a decay. All right? If B is bigger than 1, of course, if B is 1, it's linear. Because 1 to any power is 1. So B will never be 1. So if B is bigger than 1, it's a growth. If B is bigger than 1, it's a growth. If B is less than 1, it's a decay. And notice it says B has to be bigger than 0 because B will never be negative. You will never see that function in mathematics unless if you do way up there. Think about it. A negative number, let me change the color, red. A negative number to that. Well, if x is 1, then y is negative 2. If x is 2, it's 4. And so it's kind of like bouncing back and forth. And if it's 1.5, and it becomes really weird. And 1.6, it becomes weird. You know, follow all that stuff? So you won't see one of those. The negative sign will be outside of it. Okay, you won't see a negative number to an exponent. They're not even going to try to trick you. So that's why I say if b is less than 1. B has to be bigger than 0, but if it's less than 1, if it's less than 1, then it's a decay. Okay, you just kind of have to know that. Hopefully you already do. I'm sure you do. I'm sure you do. Exponential functions are always increasing. Or always decreasing. They're not always increasing. Or they're always decreasing. They don't ever switch like polynomials, right? They increase, then decrease, increase, decrease. Linears only decrease or increase. I think I'm doing it backwards. Increase. Right? So exponentials are kind of like linears. They only increase or decrease. That one's increasing the whole way because the slope is positive. This slope is negative. So this one's decreasing the whole way. And not only do they increase or decrease always, they don't ever have a local max or a minimum, or I guess they have a minimum, but I don't know if they'll do that or not. They're always concave up or concave down. That one's up, this one's up. They're both up. They will never switch concavity. They have no points of inflection. In behavior, exponential functions in general form. As input values increase, they decrease without bound. The output values will increase or decrease without bound, or they will approach 0. So the inputs always increase. The inputs will always increase, decrease without bound. So if the inputs decrease without bound, I'm going to negative infinity or positive infinity. That's the inputs, the x values. That's the end behaviors, right? Then the y values or the outputs will either be going to 0, and provided it's not shifted, or infinities. As this one decreases without bound, we're getting closer to 0. As it increases without bound, we're going to infinity. As this one decreases without bound, we're going to infinity. As it increases without bound, we're going to 0. Good enough? All this stuff, I mean, I don't know how much of this I need to teach. Limit notation, right? Limit notation. You guys did a really good job on limit notation, by the way. That you did a great job on. The notation, maybe the answer was wrong, but the notation was right. So at least I didn't have to take off for notation. One kid. All right, here we go. Example number 1. Write limit statements. Write limit statements. Write limit statements for the end behavior. Left, limit x goes to negative infinity. That has to be written with LIM and x to negative infinity underneath it. That has to be. And they didn't give me a function, so I'm just going to say f of x. But you could have said r of x or g of x or k of x, or if you want to put your name, whatever, right? As I'm going to negative infinity, I'm going to 0. I'm getting closer and closer and closer to 0. At some point, I get to 0, but the only time I get to 0 is when I get to infinity. And there's no such thing as infinity, so I never really do get to 0. I know, makes no sense. Right, limit as x goes to positive infinity. And as I'm going to positive infinity, I'm going to positive infinity. I'm not making a big deal about this because, like I said, you guys did a great job on your test. This is a reflection of a decreasing. Good? Exponential decrease. It's a reflection of it. But we still have a left and a right. Left. Right. Like I said, I was really proud of you guys for that. As we're going to negative infinity, negative infinity. As we're going to positive infinity, 0. Pretty easy with a picture. This is a exponential growth decay. Decay, because 2/3 is less than 1. Draw one if you have to. Draw one if you have to. Left, limit x goes to negative infinity fx. Limit x goes to infinity fx. Happy, happy, joy, joy. What? No! I don't want to bend down and get it. Sorry, they're taking a test over there. You can read through that? Spoil all the fun. It's not you?
No, I don't think it is.
You don't think so? Next year already? Huh. Huh. Supposed to be getting in trouble. Or you're not supposed to be getting in trouble. Okay. Example at number 2. For each of the following, determine if the exponential function is increasing, decreasing, concave, up, down. Good gracious. Is this that easy? I'm trying not to go too fast because you guys will get done with everything. A. Uphill, downhill. So it's decreasing, increasing. Concave, up, down. Up. Kind of just trying to make a smiley face, not a frowny face. So it's up, decreasing. Huh? This one's decreasing. Concave, down. Frowny face. Uh-oh. That's an exponential growth. Draw it if you have to. Growths are always increasing. And concave up. Easy peasy, lemon squeezy. Boy, it's so nice that this whole chapter is this easy. Select the values of the input are shown. Determine if it's linear, quadratic, exponential, or none. Told you, get used to this. So we have what? 5, 5, 5, 5. We have equal inputs. Equal input values. 2, 4, 8, 16. Times 2, times 2, times 2. Outputs proportional. Exponential. Not too much longer. You're going to have to write the equation for that. That's hard. Is that all the notes? Yes. Like it stops there? Yes. Okay. We're getting along better. We're getting along better.